In this video, I'm going to work through some stoichiometry with you guys. This should be a review. If at any point during this stoichiometry review, if you don't know what some steps I'm doing are, it's probably going to be best for you to email me. I know a lot of different teachers in our department teach, like for example, limiting reactant a little bit differently than I do. So I'm going to show you the way I do it, and if it doesn't make sense, like I said, please email me and I'll work you through it. So we'll work at least one of these. I may work two to see how it goes. Looking at problem number one here, we have an equation. It's a double replacement reaction, so we want to balance that. So we'll put a 2 there and a 2 there. And I should say, throughout this video, I'm going to give you a chance to pause and work ahead. And if I go a little fast, don't be afraid just to hit pause for a second and catch up, and you can rewind as well. All right, so in this problem, we have 15.6 grams of copper 2 chloride, 20.2 grams of sodium nitrate. Basically, we want to find everything. If you look at the bottom of the page, we want to know what the limiting is, what the excess is, and how much excess reactant is left over. We want to find the theoretical yield, in this case of the sodium chloride only, and then the percent yield of the sodium chloride. So a little bit of everything. Before I do this problem, I always find it easy to go ahead and find the molar masses of everything I need. So I did that using my periodic table. I got the molar mass of copper 2 chloride to be, let's start that over, 134.45 grams per mole. The sodium nitrate I got to be 85, and the sodium chloride will be 58.5 grams per mole. Wouldn't hurt you to hit pause right here and see if you can get those numbers as well. The first thing we need to do is find that limiting reactant. We'll take each reactant, and as I'm writing the numbers down here, I'm going to remind you that I do this in a much shorter way than some of the other chemistry teachers you might have had in pre-AP. If you do it the way you learned in pre-AP, that's perfectly fine. You're not going to get the wrong answers. My way is basically the same concept. I have just shortcutted the work. All I'm doing right now is writing down the mole conversions. We really can't do anything ever until we get to moles. So using those molar masses I just found. Okay, I can get the moles of each of my reactants. So for the sodium nitrate, it came out to be 0.2376 moles. And then for the copper 2 chloride, it came out to be 0.116 moles. Now here's where I do it a little different. Once I get to moles, I divide each of these numbers by the coefficient. What that does is allow me to put everything on an equal mole footing. If it was, for example, we use the hamburgers and hot dogs example in my room in pre-AP. If we have 5 patties and 4 buns, what's limiting? And because hamburgers and buns are on a per unit comparison, which would be similar to a mole, I can just say, hey, I've got fewer of the buns, 4, and only 5 of the patties, so 4 is less than 5. That works well for hamburgers and buns because there's a 1-to-1 ratio. In our equation here, it's not a 1-to-1 ratio, it's 1-to-2. So by dividing by the coefficients, I put everything back on a 1-to-1 comparison level. So I divide that, and we get two very close numbers here, 0.1188 and 0.116. Extremely close, but the 0.116 is a smaller number, and it's important to recognize that this amount is the limiting reactant, 0.116 moles of the copper 2 chloride. Okay. Once we know this limiting reactant, that is the most important piece of information. That will be the starting point for everything else we do. I'm going to go ahead and find the excess, because now that I know the limiting, to me the excess is the next logical place to go. That is a me thing. It doesn't have to be a you thing. But let's start with that amount of limiting reactant, 0.116 moles of the copper 2 chloride. Since we're in moles, we don't have to do anything else to prep. We can go right into the Stoich ratio. From the balanced equation, there are 2 moles of the sodium nitrate, which is our excess reactant, to every 1 mole of the copper 2 chloride. And then I'm going to add just one step to it to get it into grams. We've already got the molar mass, 85 grams per 1 mole for sodium nitrate. That means that we're going to use up 19.7 grams of the sodium nitrate. Again, that's used. I know in pre-AP it takes a while for students to go, okay, I realize this is not my excess, this is how much of the excess reactant that we use. We have to understand that we start out with more than we need, in this case 20.2 grams, and we've just calculated that we're going to use up 19.7 of it, so the excess is 0.5 grams. And this will be excess NaNO3. All right, let's move on now to find the theoretical yield. Again, we're going to start with our limiting reactant. We're already in moles, so get right to the Stoich. 2 moles of NaCl. That's what the problem asks us to find. 1 mole of the copper 2 chloride. We will go ahead and get the molar mass here, 58.5 grams per mole. So the theoretical yield of sodium chloride will be 13.6 grams NaCl. And that, of course, would go into this blank down here. And finally, he wants us to find the percent yield. 12.6 grams of sodium chloride are actually produced if you look at the very last sentence in the word problem. So we'll come right here, 12.6 over 13.6 grams. We'll turn this into a percentage. And if I did my math right, that's 92.6% yield. All right, we'll just make sure that we have all the blanks filled in here. Limiting reactant, we worked, was copper 2 chloride. The excess was sodium nitrate. The leftover was 0.5 grams. And the percent yield was 92.6%. All right, we're going to work problem number 2 here now. And what we're going to do this time is I'm going to give you a chance to work just one section at a time, and we'll check how we're going. And then I'll leave 3 and 4 for you to do on your own, and I'll give you the answers at the end of the video. So for right now, hit pause and balance the equation. Okay, if you got the equation balanced, you should have the coefficients of 2, 1, and 2. Hit pause again and convert both of these grams of your reactants into moles. Alright, hopefully you've done that. Alright, got the 2 moles. Now, hopefully you divided by the coefficients. I write those arrows there because I want to remind you that we're not going to use these numbers for anything other than a comparison. This comparison was pretty easy. It's quite obvious that this is my limiting amount. Okay, now we want to find the excess reactant. Hit pause. Go ahead through the entire process of finding the excess reactant. Remember, you need to find what you need and then what's actually left over, and then hit play again. Alright, we've calculated here that there's 1.14 grams of H2 used. We'll finish that off by finding the excess, 10.4 grams minus the 1.14 that we calculated using, and that was 9.3 grams of hydrogen excess. And we can go ahead and write that in our blank. 9.3 grams hydrogen. Excess was hydrogen. Limiting was O2. Alright, now we're ready to find the theoretical yield. Go ahead, pause, calculate the theoretical yield. Okay, this should be your theoretical yield of water. Just point out, we didn't talk much about molar masses of these reactants and products at the beginning of this problem because everything was real simple, H2 and O2 and water, and most of you probably have those memorized by now. But 18 grams is the molar mass of water, and that's why I have 10.3 grams of H2O as my theoretical yield. And then our percent yield, go ahead and hit pause and see if you can calculate the percent yield. That calculation is pretty simple. 8.75 grams was given in the problem statement in the last sentence, and we just found out theoretical is 10.3. Converting that into a percentage, rounded up to 85% for the yield of this reaction. Okay, at this point, if you have any questions, send me an email. If not, go ahead and start on problems 3 and 4. I'm going to give you the answers here with a longer pause. But go ahead and hit pause if you haven't done number 3 yet, and give it a shot. Alright, let's see how you did on problem number 3. The coefficients were 1, 2, and 1. And with those coefficients, you should have calculated a theoretical yield of 8.51 grams of methanol. The limiting reactant was carbon monoxide. The excess was hydrogen. The excess was 0.14 grams of H2. And the actual yield, a little bit different in this problem, is that we were given the percent yield, so your calculation was 0.884%, or it's not a percent anymore, it's decimal form. times the theoretical, and that gave us the actual yield of 7.52 grams of CO. All right, let's do the same thing with number 4. Pause and work it if you haven't already. And the last piece here, problem number 4. A little bit harder to balance, if you want to use the word hard. Your coefficients were 6, 1, 3, and 2. And when you're doing Stoich, obviously your coefficients are a pretty big deal. Your limiting reactant was the iron 3 sulfate. And the excess was the sodium hydroxide. Your leftover was only 0.38 grams of the sodium hydroxide. The theoretical yield was 6.11 grams of the sodium sulfate. And the actual yield, 4.85 grams of the sodium sulfate. Okay, that's a good refresher. If you have any questions about how to do that, especially limiting reactants, since I know many of you learned from Mr. Beimer or Mr. Rollins or Ms. Sloan how to do limiting reactants in a little different way. If you have any problems, email me and we'll talk about it.